Alright guys, welcome to this class. In this class we are going to look at the chemistry past questions and then provide solutions to them. We are going to look at, we've already discussed the episode 1 and episode 2, and this will be episode 3. Now the first question here says that a species with atomic number 8 and 10 electrons is likely to be a species with atomic number, let's use AN for atomic number, equals to 8 and the number of electrons equals to 10 is likely to be A, neutral atom, B, an ion, C, a cation, D, non-existent. For us to be able to provide solution to this question, we must be able to understand the composition of the atom. We are told that the atom comprises of 3 subatomic particles, which are the proton, the neutrons, and the electrons. The protons are positively charged, the neutrons are neutral, and the electrons are negatively charged. It should also be noted that the number of protons is equal to the number of electrons for any neutral atom. Also, we should also pay attention to the fact that the number of protons is equal to the atomic number. So we can say that the number of protons for this particular question is also what? 8. So this atom has 8 protons and then it has 10 electrons. Having known that the number of protons is equal to the number of electrons for neutral atom, it means that for a neutral atom, we are supposed to have 8 what? Proton and electron. But something happens. Whenever an atom gains or gives out electrons, ions are formed. Now, please take note of this, that whenever an atom gives out electron, the number of electrons will reduce or will be lesser than the number of protons, and it will form a cation. Whenever an atom gives out electron, the number of electrons reduces to form a cation. Are we getting it now? So, and whenever it accepts, the number of electrons will be greater than the number of protons, which is the atomic number. And what will happen? An anion will be formed. So for this case, for the electron to be 10, it means that that atom has accepted 2 more electrons. And because it has accepted 2 more electrons, this atom is said to be what? Is said to be this particular ion is what? An anion. So an atom that has the number of electrons greater than the number of protons, or the number of electrons greater than the atomic number, is an anion. Is that clear? For instance, let's look at oxygen. Oxygen has atomic number of, let's say oxygen 2 minus. Oxygen has atomic number of 8, that is 8 proton and 8 electron. 8 proton and 8 what? Electron. But because of these 2 additional electrons, what are you going to do? To calculate the total number of electrons here, you add 2 to it, and this gives us 10 electrons. Are we getting it now? So that is the case for this question. So the correct answer is an anion. Number 2, a nuclide with formula X 18 8 contains dash proton, dash electrons, and dash neutron. What is the nuclide formula? Now, a nuclide formula is a formula that shows the composition of an atom or the composition of the nucleus. The nuclide formula shows what? The composition of the nucleus. Are we getting it now? The nuclide formula comprises of 3 most important things, and those are the atomic symbol, which in this case is this. The atomic symbol comprises of the atomic symbol, the atomic mass, which is a superscript to the left of the atomic symbol. The atomic mass is a superscript. Superscript is what? Up to the left of the atomic symbol. And then the atomic number, which is a subscript to the left of the atomic symbol. It should be noted that the number of proton, the atomic number, is equal to the number of proton. Equals to the number of proton. Now, this question, we are looking for the number of proton, number of electron, and number of neutron. Now, the number of proton is equal to what? Is equal to 8, because we said the atomic number is the number of proton. Atomic number is equal to the number of protons. So since the atomic number is equal to 8, it means that the number of proton must be equal to 8. Now, the next one is, we should also know that for any neutral atom, this atom is a neutral atom, the number of protons is equal to the number of electrons. So if the number of proton is 8, it means automatically the number of electron is 8. Also, one should know that the number of proton plus neutron is equal to the atomic mass. Number of proton plus neutron is equal to the atomic mass. Please note this. This is the formula. That is to say that the total mass of the atom is the addition of the mass of the proton plus that of the neutron. So, the number of proton is what? 8. Plus the number of neutron is unknown, is equal to the atomic mass. We said the atomic mass is 18. So to get the number of neutron, what do? Take this to this side, it becomes 18 minus 8, and this gives us 10. So the number of neutron is equal to 10. So our answer is 8, 8, 10. And that is option D for this question. Let's take a look at the next question. What is the most stable ion of aluminium? What is the most stable ion of aluminium with proton number equals to 13? What is the most stable ion of aluminium with proton number is equals to 13? If you've watched episode 1 and 2, you agree with me that I said that the most stable ion of any atom is the number of electrons that ion must give out or receive to get to a noble gas configuration, or to obtain an octet structure, or to obtain octet. The number of electrons that an atom must give out or receive to gain octet is the most stable ion. Are we getting it now? The most stable ion. Now, of course, you know that the number of if it gives out, it becomes positively charged, while if it receives, it becomes negatively charged. So for aluminium, the electronic configuration is 283. Now this is the most stable state. So aluminium has the tendency of giving out 3 electrons. If it gives out 3 electrons, it becomes what? Octet complete. Are we getting it now? So the most stable ion, if it gives out 3 electrons, it becomes 3 plus. That means it has excess of 3 protons. It has excess of how many protons? 3 protons. How many protons? 3. So the most stable ion of aluminium is aluminium 3 plus. What of oxygen? Let's try for oxygen. Oxygen has atomic number of 8, which is 2 and 6. Because of electronegativity, oxygen cannot easily give out electron because it's almost close to octet. Unlike, to get to octet, this one needs 5. You need 5, and you have 3 that you can give to somebody that needs 5. Who will easily give out? You that have 3 will give out to the one that have 5, so that you both will complete 9. Are we getting it? Same thing is applicable here. Oxygen is having 6. So oxygen will be battling with another element that has 2. Are we getting it now? So between oxygen and that element, who will give to who? You agree with me that the element will give to oxygen, isn't it? Now, giving to oxygen to complete octet, it gives 2 electrons. Now, we know that whenever atom receives electron, they become negatively charged. So this becomes 2 minus. And the most stable ion for oxygen is O2 minus. So that is the reason why that of aluminium is plus 3, because aluminium can easily give out 3 electrons to obtain what? Octet. Is that clear? Aluminium can give how many electrons to obtain octet? 3, because the electronic configuration is what? 283. 3 can easily go out to meet with somebody that has 5 than collecting 5 from someone to complete what? The octet of 8. Is that clear? So that is that for that question, and the correct option is option A. Next question. What is the force of attraction between molecules, between butane molecules? What is the force of attraction between butane molecules? A. Ionic bond, B. Covalent bond, C. London forces, and D. Hydrogen bonds. Now, the force of attraction between covalent molecules is known as what? The London forces, or the London dispersion forces. That's the force of attraction. Because between the molecules themselves, are we getting it? Any molecule that do not undergo covalent bond, that do not undergo ionic bond, that do not undergo dipole-dipole, undergoes what? London forces. So the force of attraction between, not within. Now within them, they undergo covalent bond, but between them, that means between one butane molecule and another, is London dispersion force, or you can call it what? London forces. Are we getting it now? London forces is present in all molecules. Are we getting it? In all molecules. So that is that. The next question says, what is the electronic configuration of copper in its ground state? What is the electronic configuration of copper in its ground state? To provide solution to this question, you must understand something very, very important. And that is the fact that the d orbital confers more stability. That is to say that the d orbital have a more stable configuration when the d orbital is not filled at all, halfly filled, and completely filled. It confers more stability, that it is more stable when it is not filled at all, halfly filled, and what? Completely filled, as opposed to when it is partially filled. Now, the d orbital can take a maximum of how many electrons? 10. Halfly filled means it should have 5 electrons in its outermost shell. Completely filled means it should have the complete 10 electrons. While not filled at all means there should be no electrons. Are we getting it now? Now, you agree with me that copper is a transition element. That is to say, it has its last electron go into a d on an f orbital. For this case, it's a d transition element. So, because copper is a d transition element, it has its last electron go into a d orbital. And because it goes into a d orbital, it is for it to be filled, or when you fill the electronic configuration, when you see that it gets to almost 10, what is wise to do is to promote the electron to make it 10. Now, by illustration, you understand better what I'm trying to say. For instance, copper has atomic number of 29. Now, writing the electronic configuration for copper, you have it as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d9. Let's count. This is 10, 10, that's 20, 29. By convention, this should be the electronic configuration for copper. But because this d orbital is almost filled, like we said that when the d orbital is filled, it actually obtains more stability when it is completely filled, when it is halfly filled, than when it is partially filled. So if you have the leeway, what it takes to actually promote one electron to make it completely filled so that it will be more stable, you should do that. Are we getting it now? If you have the leeway, that means if you can just promote one electron to make it to be more stable, why not do it? That is what is happening here. Are we getting it now? So we promote one electron from here to this place, and the electronic configuration becomes 4s1, 3d10. You see that now it is not completely filled. So this is the most stable electronic configuration for copper. Now, this thing is also obtainable when you come to chromium. Chromium has atomic number of 24, and the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 3d4. This is the normal electronic configuration. But you see that we can easily promote one electron here so that it will be halfly filled, because we said that when it is halfly filled, when it is completely filled, they confer more stability than when it is partially filled. So whenever you have it in such a way that you can easily promote just one, not two. If you promote two, then you are wrong. Just one. Not that when you have 8 here, then you now promote 2 from here to become 0. It doesn't work like that. Are you getting it? You promote just one so that they will work on pair. You know this. If you write the orbital diagram for this, it will be like this. So you promote just one electron from here so that one will be left here. Are we getting it now? So same thing is applicable here. For it to be halfly filled, which will confirm more stability, promote one electron from here. And this gives us 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. And this is the electronic configuration for copper. Is that clear? Or for chromium rather. Electronic configuration for chromium. Now, let's look at, and that is the electronic configuration for chromium. But for this particular question, the options given to you is in the condensed form. Now, the condensed form suggests that you take the nearest noble gas, write it in the condensed form, then continue like that with the other orbitals. The nearest noble gas is argon, isn't it? The nearest noble gas is argon. Now, the atomic number for argon is 18, so you count 18 out of this. This is 4, 10, 12, 18. So from here to here now means is the electronic configuration for argon. Now, why are we doing this? In order to condense it. Are we getting it? So that you'll not be writing all this. So in place of this whole rubbish here, you put what? Argon, A arrow, then you put 4s1 and 3d10. So this is the electronic configuration for copper. The next question says, which contains exactly 8 protons? Which contains exactly 8 protons? You have sulfur 32, then you have nitrogen 14, carbon 14, oxygen 16. Now, this question is a question that requires you to think logically. Are we getting it? Which contains exactly 8 protons? Now, we said that the number of proton is equal to the atomic number, isn't it? What they ask you here, which element has atomic number of 8? Which element has atomic number of 8? So, among all these that are given to you, you have your options: sulfur 32, nitrogen 14, carbon 14, and oxygen 16. Which of them has atomic number of 8? Of course, you know that the element that has atomic number of 8 is oxygen. All this you are seeing here, they are the what? Number of the mass number. And the mass number is approximately 2 times the atomic number. The mass number is approximately 2 times the atomic what? Number. Some of them are exact, but some are approximately. So if you multiply this by 2, it gives you 16. And that is the element in question. The next question says, how many sub-energy levels are in an atom with principal quantum number n is equals to 3? How many sub-energy levels are in an atom with principal quantum number n is equals to 3? Now, the number of suborbital in any atom is given by n squared. Number of orbitals is given by what? N squared. Where n is the principal quantum number, while the number of electrons in that orbital or shell is given by 2n squared. Number of electrons in a shell This is number of orbitals in a shell. So this gives us n squared, number of orbitals. That was what we asked for. And this gives us 3 squared, because we asked when n is equals to 3, how many sub-energy levels are in an atom? Principal quantum number n is equals to 3. The sub-energy levels are also called the what? Orbitals. So that is 3 squared, and 3 squared will give us what? 9. So we have 9 sub-energy level.